Good afternoon, everybody. This is Miss Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyad. In the previous class, we were discussing about how to solve the inverse Z transforms using the method of power series. There were some standard expansions which we used to know, which we should remember. By using those standard expansions, we can solve the questions in an easier way. However, solving using partial fractions, method of partial fractions is the easiest one, and you should concentrate mainly on that topic. So we will discuss in today's class regarding what you mean by difference equations. What is difference equations and how to solve difference equations using Z transforms. These things we will discuss. Our main applications of Z transform is to solve these difference equations. So we have learnt in our second semester regarding forward difference, backward difference, and how it is done. So we used to have a function, say y is equal to f of x and x naught, x1 equal to x naught plus h, x2 equal to x1 plus h, etc. These were the equidistant points. Xn is equal to xn minus 1 plus h. These were the points where the function is defined. These were the equidistant values of x with a distance h. This is the common distance h. And the corresponding values of y equal to f of x used to be corresponding to each of these values. We used to have the y values as y naught is equal to f of x naught, y1 equal to f of x1, y2 equal to f of x2 plus etc. yn equal to f of xn. These were the corresponding values for the values of y for different values of x. We have found this, we have learned about this, and how the forward difference is denoted as. Forward difference operator is delta, and it is denoted as delta f of x is equal to f of x plus h minus f of x. And say for a particular value x equal to x. Yes?
Ma'am, that screen is not visible, ma'am.
To everyone or only to Shilpa?
It's visible, ma'am.
Okay. Check your connection with Shilpa. Okay. For the values of x equal to x naught, delta f of x naught is equal to what it will be? F of x naught plus h minus f of x naught. Say for a particular value of x star, x that is equal to x naught, it is defined to be delta f of x naught is equal to f of x naught plus h minus f of x naught. And x naught plus h can be written as f of x1 minus f of x naught. In general, we used to write this as, say, delta yn is equal to yn plus 1 minus yn. If we go up to nth term, this used to be the nth term. So what do we get here? We get the difference between the successive term and the next term. The term and its successive terms. We get the difference between them. So these kind of equations are known as difference equations. These kind of equations are known as difference equations. So equations of the form. This one we have got it one over here. When we continue, we will get some. Okay, when you continue like this, we will get some equations which are of the form yn plus 1 minus yn, yn plus 2 minus yn plus 1 equal to 0. This is equal to 0. So we are getting the difference over here between the two terms. So these kind of equations are known as difference equations. In other words, what you call a difference equation, it is a relationship. It is a relationship between the differences of an unknown function. It is the relationship between the differences of an unknown functions. Yn plus 2 and yn plus 1, they are the unknown functions. So here we are getting the differences, the relationship between the differences of an unknown function at several values of the independent variable. Not only for one or two values, for different values of the several variables. If you are able to find the relationship between the two unknown functions, then we say that such equations are known as difference equations. What is a difference equation? It is a relationship between the differences of an unknown function at several values of the independent variable. So the general form of the difference equation is given by as yn plus r plus ar. ar minus 1 yn plus r minus 1 plus ar minus 2 yn plus r minus 2 plus etc. a2 yn plus 2 plus a1 yn plus 1 plus a0 yn equal to some phi of n. So this is the general form of an difference equation. You will not have such long difference equation. We will have up to the degree 2. Okay, we will have the difference equation up to the degree 2. So in this class we will be learning how to solve, how to find the solution, because any linear differential equation will have a solution. Okay, and y constitutes the solution of the difference equation. If we are able to find the value of y, we are able, that means we have found the values, find the solution. We have found the solution of that differential equation. That's how we used to do it while solving the differential equations. If we are able to find the value of y, that means we have found out the solution of the differential equation. So here we have a difference equation. If we get the value of y, that means we have found the solution of that. And it will have some arbitrary constant like any other differential equation, and that arbitrary constant is equal to the order of the differential equation. So here we will be dealing with the difference equations. What you need to know here is there are some applications and the properties which we have already discussed over there. So from the definition of Z transforms we have, if Z transform of un is what? It is denoted by u bar of z, that is summation n equal to 0 to infinity un z power minus n. This is from the definition of Z transforms. Then there is a formula which we have learnt in left shifting rule, that is zt of un plus 1, that is equal to z into u bar of z minus u naught. Next one we have z transform of un plus 2. What is this? This is z square into u bar of z minus u naught minus u1 by z, or you can write it as u1 into z power minus 1, which we have used these while solving, while finding u naught, u1, u2, etc. I hope you remember that. The same formulas are these. This we need to use while solving the questions. So let's begin with the first question. What we need to do is, suppose if they ask you to solve a difference equation which is given as un plus 2 is equal minus 5 un plus 1 plus 6 times un equal to 0. Un plus 2 minus 5 times un plus 1 plus 6 times un equal to 0. Suppose if this difference equation is given, and if we are asked to solve this, that means you need to find the solution of this. What we do is we take z transforms on both sides. So when we take z transform on both sides, we get z transform of un plus 2 minus 5 times z transform of un plus 1 plus 6 times z transform of un, that is equal to z transform of 0. Okay, now next, just now I have given the formula for z transform of un plus 2. These things you need to remember: z transform of un plus 1 and z transform of un plus 2. So what is z transform of un plus 2? It is z square into, we'll write over here, it is z square into what? U bar of z minus u naught minus u1 into z power minus 1 minus 5 into z transform of un plus 1. What is z transform of un plus 1? It is z into u bar of z minus u naught. Then plus 6 times, what is z transform of un? It is u bar of z by the definition of z transform, and z transform of 0 is 0. Now next step, what we do is we combine the terms which has u bar of z. You combine the terms which has u bar of z. The coefficients of u bar of z. What are the coefficient of u bar of z? z square into u bar of z. So coefficient of u bar of z is z square. Then here u bar of z is 5z. Then where else u bar of z is there? Here. So it is 6. So this is the coefficient of z square. After we find the coefficient of u bar of z, what we do is we find the coefficient of u naught. Okay, so I'll take minus u naught outside. What is the coefficient of u naught? Z square. Where else we have the coefficient of u naught? Here it is. It is what? Minus 5z. Am I correct? Minus 5z. This is the coefficient of u naught. Afterwards, find the coefficient of u1. What is the coefficient of u1? What is the coefficient of u1?
Z square.
Z square into, here it is, here z square into z power minus 1. So what it will become? Z power 2 into z power minus 1. 2 minus 1. So it is z power 1. Here there is z power minus 1 is also there. So z power 2 into z power minus 1 is z. So coefficient of u1 is z. So that is equal to 0. Next step what we do is z square minus 5z plus 6 into u bar of z. We take this entire term to the other side. It will become u naught into z square minus 5z plus u1z. We take this entire term to the other side. Okay, now because we want to have this u bar of z, that's why I separate the terms. Because at the end I want to write u bar of z and I need to find the inverse z transform of that, so that I get the solution of this. So what is u bar of z from this? Take this term to the other side. What do we get? It's u naught into z square minus 5z divided by z square minus 5z plus 6. This we have to take it to the other side. Here also plus u1 into z divided by z square minus 5z plus 6. This is what we get when we take this term to the other side. It comes over here in the denominator. Am I correct? Yes or no?
Yes, ma'am.
Okay. Next, now what we do is we apply inverse z transform on both sides. That is zt inverse of u bar of z, that is equal to u naught into zt inverse of z square minus 5z divided by z square minus 5z plus 6 plus u1 into inverse z transform of z divided by z square minus 5z plus 6. Now we need to find the inverse z transform of each of these terms. So that is the work which is left over here now. So how do we do it? What we do is I take this as p of z and I take this as q of z. So let p of z is equal to z square minus 5z divided by z square minus 5z plus 6. Is it okay? Now next step, see, whenever if there is a quadratic equation, I told you all you should split them. You should write them as a product of linear factors. How can you write it as 5z plus 6? See, we know 6 is 3 2s are correct, but we want minus 5 over here. So if you put minus 3 minus 2. Minus 3 minus 2 is minus 5, minus 3 into minus 2 is 6. So how you can write it as z square minus 3z minus 2z plus 6. So it is z into z minus 3, and if you take minus 2 outside, z minus 3. So what are the linear factors? Z minus 3 into z minus 2. Is it okay, everyone? How to split z square minus 5z plus 6 as a product of linear factors? It is like finding the roots. Is it okay?
Yes, ma'am.
Okay. Anybody else has any doubt? Anybody wants me to repeat this step? Is it clear? Amog, is it okay?
Yes, ma'am.
Okay. Now, so 5z square minus 5z divided by, it will be z minus 3 into z minus 2 in the denominator. Then Next step. Now we can solve this using the method of partial fractions. We have solved this. First step, when you have p of z, what we do? We find divide by z on both sides. So numerator z square can be written as z into z minus 5. Am I correct? If you take z outside from the numerator, it will be z into z minus 5. So if you divide by both sides, the z get cancels. Z minus 5 divided by z minus 3 into z minus 2 remains if you divide both sides by z. Now, next step what we do is, here only I'll write, you can write this as a divided by z minus 3 plus b divided by z minus 2. This is after applying the concept of partial fractions. So next what we do here, we multiply by z minus 3 into z minus 2 on both sides. We multiply by z minus 3 into z minus 2 on both sides. So what happens when you multiply by z minus 3 into z minus 2? Here when you multiply, it will get cancels, z minus 5 remains. So entire thing you multiply over here, z minus 3 get cancelled. So what will remain? A into z minus 2 plus b into, if you multiply over here z minus 2 into, if you multiply z minus 3 into z minus 2, what happens? Z minus 2 get cancels, b into z minus 3 remains. Is it okay?
Yes, ma'am.
Okay. Next, now find the value of a and b. In order to find the value of a, we shall put z equal to 3. If you put z equal to 3, 3 minus 5 is minus 2, that is equal to a into z is 3 minus 2 plus b into 3 minus 3. This will become 0. So 3 minus 2 is 1, a value is minus 2. Am I correct? Yes or no?
Yes, ma'am.
Okay, next. Now put z is equal to 2. What happens when you put z is equal to 2? 2 minus 5, that is equal to a into 2 minus 2 plus b into 2 minus 3. 2 minus 3 is minus 1. This is 0. 2 minus 5 is minus 3 is equal to b into minus 1. So what is the value of b from here? 3. Am I correct?
Yes, ma'am.
Okay, so a value is minus 2, b value is 3. See, it depends on what you take here in the denominator. If you take a divided by z minus 2 and b divided by z minus 3, a and values will be, b values will be different. Okay, so do not get confused with that. Your a and b values may be interchanging. It doesn't matter. It depends on how you have taken that, the term in the denominator. It completely depends on that. So next step, what do we do now? Let's substitute a and b in the here, over here. What happens? From star, p of z divided by z, that is equal to z minus 5 divided by z minus 3 into z minus 2, that is equal to a value is what? Minus 2 divided by z minus 3. B value is what? 3 divided by z minus 2. So this is p of z divided by z. So what is p of z from this? Multiply by z everywhere. What happens when you multiply by z everywhere? It will be minus 2 into z divided by z minus 3 plus 3 into z divided by z minus 2. Am I correct? It was p of z divided by z. So I multiplied by z on both sides. So I get minus 2 into z by z minus 3. Here also 3 into z by z minus 2. Is it correct? Are you all able to follow this? Yes or no?
Yes, ma'am.
Okay. Now take
Yes,
the
ma'am.
inverse. Now take the inverse. What is the inverse z transform of p of z? It is nothing but minus 2 into inverse z transform of z by z minus 3 plus 3 into inverse z transform of z by z minus 2. So what do we get from here? Minus 2 into, what is the inverse z transform of this?
3 power n.
Yes, very good. It is 3 power n plus 3 into what is the inverse Z transform of this?
2 power n.
2 power n. So this is what? This is the inverse Z transform of Z square minus 5Z divided by Z square minus 5Z plus 6. Remember this inverse Z transform of Z by Z minus K is K power n. Here Z by Z minus K. In place of K we have 3, so it is 3 power n. Here we have 2, that's why it's 2 power n. When you have K equal to 1, it will be 1 power n, which is 1. Okay, so what we have found over here now, we have found this P of Z, we have found inverse Z transform of P of Z, we have found. Now let us find inverse Z transform of Q of Z, where what is Q of Z? Z divided by Z square minus 5Z plus 6. Z divided by Z square minus 5Z plus 6, and the denominator can be split into Z minus 2 into Z minus 3. Okay, so this is Q of Z. Next, when you apply the method of partial fractions, you need to divide by Z on both sides. So what happens when you divide by Z on both sides is 1 divided by Z minus 2 into Z minus 3. Okay, now next you can split this as a divided by z minus 2. We have taken already a, so we will take it as c divided by z minus 2 plus d divided by z minus 3. Next what we do is we multiply by z minus 2 into z minus 3 on both sides. We multiply by z minus 2 into z minus 3 on both sides. What happens when you multiply by this term? The entire term get cancelled. So 1 is equal to c into. Here also when you multiply z minus 2 and z minus 2 get cancelled. Z minus 3 remains plus d into. When you multiply z minus 2 into z minus 3, z minus 3 get cancelled. So d into z minus 2 remains. So next step what we do is we shall put z equal to 2. When you put z equal to 2, this term will become 0, so that we get the value of c. So 1 is equal to c into 2 minus 3 plus d into 2 minus 2. So this term will be 0. C into 2 minus 3 is minus 1. So what will be the value of c? It is minus 1. Now in order to find the value of d, you should make the coefficient of d 0. So in order for that, what we should do, we should put the value of z as 3. So 3 minus 3 will be 0. So let us put z equal to 3. What do we get? 1 equal to c into 3 minus 3 plus d into 3 minus 2. So this term will be 0. 3 minus 2 is 1. Therefore value of d is 1. Anybody has any doubt in this?
No, ma'am.
Anybody, any doubt? Okay. Now let us put the value in here. Q of z divided by z equal to 1 divided by z minus 2 into z minus 3. That is equal to, substitute the value of c and d over here. C is minus 1 divided by z minus 2 plus d value is 1 divided by z minus 3. Now Now what is q of z? Multiply by z on both sides. We get z into minus 1 divided by, so it is nothing but you can write it as minus z divided by z minus 2 plus z divided by z minus 3. Now take the inverse z transform. What is the inverse z transform of q of z? It is nothing but minus inverse z transform of z divided by z minus 2 plus inverse z transform of z divided by z minus 3. Now tell me, what is this inverse z transform of z divided by z square minus 5z plus 6? That is equal to, what is the inverse z transform of z by z minus 2? What is it?
2 power n.
It is 2 power n. Similarly over here, what is the inverse Z transform of this? It is 3 power n. So now we have found out these things. Let's substitute over here. Where? Here in this main example. In this main, we'll put it as double star. We have found this term. We have found this term. So write the final expression. What is the T? Inverse Z transform of U bar of Z. What is inverse Z transform of U bar of Z? That is nothing but U naught into the inverse Z transform of P of Z. What is inverse Z transform of P of Z? Here it is. It is 3 into 2 power n minus 2 into 3 power n. It is 3 into 2 power n minus 2 into 3 power n plus u1 into the term whatever we got it just now. This one. 3 power n minus 2 power n. So now we know that Z transform of U n is equal to U bar of Z. Z transform of Un is equal to U bar of Z. So what will be inverse Z transform of U bar of Z? It is Un. So what is this one? This is nothing but Un. That is equal to, what do we get from this now? What do we get from this now? How can we write this as? See, what we do here is, we will split these things as power of 2 power n and 2 power n, coefficient of 2 power n and coefficient of 3 power n. So first you combine the coefficient of 2 power n plus then you combine the coefficient of 3 power n. What happens when you take the coefficient of 2 power n? It is 3 u0 and here we have minus u1, minus u1. Now take the coefficient of 3 power n. Coefficient of 3 power n is u1 minus, here also we have minus 2 into u0. So it is minus 2 u0. Is it okay? What I have done? I have taken the coefficient of 2 power n and coefficient of 3 power n. So I can write un as some c1 into 2 power n plus c2 into 3 power n. Where what is c? It is 3 u0 minus u1. What is c2? It is u1 minus 2 u0. Where c1 and c2 are arbitrary constant because it contains the terms u0 and u1, and we know that u0 u1 are the constants. Where we have found that how to find those constants also we have discussed in the last topic. So this is the solution. In order to, we finally have to find what is un. So that is gives us the general solution of the difference equation. Is it okay, everyone? Is it okay?
Yes, ma'am.
Okay. So it is very easy, but it is little lengthier. Okay, nothing much is there in that. So I will discuss one more question, which is this previous one was quite lengthy. So I have one small question. We'll discuss this question so that the concept is very clear for you all. So what is it given is, we need to solve the Z transform, which is given as yn plus 2 minus 4 times yn equal to 0, given that y0 equal to 0 and y1 equal to 2. Yn plus 2 minus 4 times yn equal to 0, y0 equal to 0 and y1 equal to 2. Okay, so first thing what we need to do is, we need to apply Z transform on this equation. That is Z transform of yn plus 2 minus 4 times Z transform of yn, that is equal to Z transform of 0. So what is Z transform of yn plus 2? It is same as Z transform of un plus 2. Only the variable is different. So this is nothing but Z square into u bar of Z minus u0 minus u1 into Z power minus 1. So but here you have y, that's why you need to change the variable as y. So it will be Z square into y bar of Z minus y0 minus y1 into Z power minus 1. Is it okay? That variable you need to change, nothing else. The formula remains the same thing. U is changed to y now. Is it okay, everyone? Yes or no?
Yes, ma'am.
Sonia, are you all sleeping? Apeksha, Prashant, is it okay?
Yes, ma'am.
Okay. Now, what is Z transform of yn minus 4 times y bar of z? Because Z transform of yn is y bar of z. So that is equal to Z transform of 0 is 0. Next step what we do is we take combine the coefficient of y bar of z. What is the coefficient of y bar of z? Here it is z square and then one more is minus 4. So this is the coefficient of y bar of z. Then what else is remaining? See here, there are two conditions as well. Y0 is 0, y1 is 2. So y0 is 0, y1 value is 2. So what remains now? This is going to be 0. This we have written, this term also we have written. So only this term remains now. That is minus 2 into z power minus 1 into z square. See this is y1 value is 2, 2 into z power minus 1 into 2. So it will be plus 1. That is equal to 0. This is what we get it. Now from this write what is y bar of z. Y bar of z, you take this minus 2z to the other side. It will be 2z divided by, this goes to the denominator. That is 2z divided by z square minus 4. Is it okay everyone? Anybody wants me to
Yes,
repeat any
ma'am.
step? We first combine the coefficient of y bar of z, you get z square minus 4. Then y0 is 0 given in the question, y1 is 2, so 2z power minus 1 into z power 2. So it is 2z. Here we get. So what is y bar of z? 2z divided by z square minus 4. Done. Next we shall apply the method of partial fractions. Y bar of z is 2z divided by z square minus 4. So what will be y bar of z divided by z? Y bar of z divided by z is 2 into, see, z square minus 4. Z square minus 4, that will be z square minus 2 square. A square minus b square is a plus b into a minus b. Am I correct? Z square minus 4, that is z square minus 2 square, a square minus b square, which can be written as a plus b into a minus b. So the denominator can be written as z plus 2 into z minus 2. Done. Now I will split this into a divided by z plus 2 plus b divided by z minus 2 by the method of partial fractions. Is it clear everybody? Anybody has any doubt? Please ask. Those who have attended my class on method of partial fractions, they are going to find it easier because we have discussed this in detail over there, isn't it? Yes or no?
Yes, ma'am.
Vaishnavi, are you there? Bhagyashri, any doubt?
Ma'am.
Okay, done. Now what we do? We shall multiply by this denominator, that is 2 into z plus 2 into z minus 2 everywhere. Here also z plus 2 into z minus 2, here also z plus 2 into z minus 2. So when you multiply here, denominator and numerator get cancels, here z plus 2 get cancelled. So a into z minus 2 remains plus b into, when you multiply over here, z minus 2 get cancels, z plus 2 remains. Now we need to find the value of a and b. In order to find a, we need to make the coefficient of b 0. That z plus 2 has to be made 0. So for that, if z plus 2 is 0, that means I need to put the z value as minus 2. So 2 is equal to a into minus 2 plus b into minus 2 plus 2. So this term will be 0. A here we get minus 4. So what is the value of a? It is 2 divided by minus 4, which is nothing but minus half. Am I correct? Yes or no? What happened? Mega, any doubt? Chaitranjali. Amog,
Yes, ma'am.
is it okay?
Yes,
Yes,
ma'am.
ma'am.
No doubt, ma'am.
Okay. So A is minus half. Is that clear?
Yes, ma'am.
Okay. Next, we shall put z equal to 2. If you put z equal to 2, what happens? Here it will be 0. So 2 is equal to A into 2 minus 2 plus B into 2 plus 2. So 2 plus 2 is 4. This will be 0. So we get what? B equal to 2 by 4, which is nothing but half. So substitute A and B over here. What do we get then? Y bar of z divided by z, that is equal to 2 divided by z plus 2 into z minus 2, that is equal to A value is minus half into 1 by z plus 2 plus B value is what? Half into 1 by z minus 2. This is what? Y bar of z divided by z. Next, find y bar of z. What is y bar of z? Multiply z on both sides. So we get minus half into z by z plus 2 plus half into z by z minus 2. Next step is find the inverse z transform of y bar of z. That will be minus half into inverse z transform of z by z plus 2 plus half into inverse z transform of z by z minus 2. Now tell me, what is the inverse z transform of y bar of z? It is yn, that is equal to minus half into, what is the inverse z transform of this? What is it? So z plus 2 can be written as z minus of minus 2. So k will be minus 2. Inverse z transform of this is minus 2 power n plus half into inverse z transform of what? This is of that form only. Inverse z transform of z by z minus k, which is k power n. So k here is 2, so it will be 2 power n. Okay, now how we can write it as yn is equal to, so here you can write it as, see here, minus 2 power n divided by 2. Am I correct? Isn't it? So this can be written as minus 2 power n divided by minus 2 plus 2 power n divided by 2. Am I correct? Same thing. I have not written it in some other form. So minus 2 power n by minus 2 can be written as minus 2 power n minus 1. Similarly, this one also we can write it as 2 power n minus 1. Am I correct? Minus 2 divided by minus 2 will be minus 2 power, it will be 1. So when you take it to the numerator, it will be minus 1. Similarly over here, 2 power 1. When you take it to the numerator, it will be 2 power minus 1. So it is 2 power n minus 1. So this is the solution of the differential equation or the difference equation. Is it okay, everyone?
Yes, ma'am.
So we'll wind up today's class over here because there is a lot of disturbance over here. So if you have any doubt, work out only these questions. Okay, these questions you will work out. More questions we'll discuss on Monday. Okay, we'll meet in the next class. If you have any doubt, please contact me. Okay, for your doubts, please contact me. If you have any doubts, please ask. Okay, and work out the questions which I have solved in today's class. You can go through the question, okay, and work out the same question. Be prepared for it. If any doubt, please contact me. Thank you, everybody. Let's
Thank
meet in
you,
next
ma'am.
class.